Hey everyone, in this video I want to explore using multiple regions for our application architecture and thinking about some of the implications of which region we actually choose. Now when I architect my solution, I'm really thinking about maybe levels of failure that can occur at different blast radiuses, and also having instances of my service in multiple locations so I have improved end user experience as they're geographically distributed and they can use an instance closest to them. And if I think about, well, what can happen? What are the different types of impact and what levels those impacts hit at? Well, we can really kind of build up. I can think about, well, obviously there's an operating system. So there's some OS, and then I write my application. So then I have my app, and I can have OS problems that can occur. It could have an issue. It can have a crash. There could be a driver problem. My application, I could have some bad code. The app could crash, but the OS carries on running quite happily. And obviously that sits inside a certain type of resource. Maybe it's a virtual machine, but that virtual machine is running on a physical piece of equipment. So it's running on a particular host. And obviously that host is made up of components. It can have a power supply unit failure, and there's redundancy built in that can really only go so far. That host itself sits on a certain rack. That rack has its own power supply units, again, resilient. It has network rack switches in there, which again are resilient, but things can happen. So I think of, hey, something could happen at the rack level, something could happen at the host level, OS, app. And then obviously this rack itself, let's shrink this down just so I can make things a little bit easier. So if we've got this rack, well, that rack itself is part of a cluster at a fabric level in Azure. And the cluster, well, it lives within a certain data center. And I can think about those data centers have their own power coming in. They have their own generators. They have their own AC units, fire suppression systems. But things would happen at a data center level as well. So massive cooling failure, electrical failure, a fire. And then we can think about, well, there's actually lots of data centers. So I'll make those a bit smaller. But there's many, many data centers that make up these particular regions that we see in Azure. So I can then think about this idea of, well, we have this entire region in Azure. And there could be something unlikely that could take out the entire region, some kind of natural disaster, some event that could maybe take out the whole region. Now, when Microsoft plans the different land parcels they purchase to put on the data centers, they configure things like floodplains and fault lines and availability of multiple power supplies and multiple network connections. But hey, things can happen. So yes, there are many types of impact. Hardware failures of a server, of a rack, of a cooling system. Software failures, your app, your OS, maybe some software, the Azure Fabric itself introduced at maybe a cluster level. Failure could also be, hey, some huge spike in traffic and just the capacity I've put aside can't keep up with that. So the perceived effect is, hey, it failed. It didn't fail. It's just stress beyond what it can handle. But for the end user, it's not getting the response they expect, and so it's failed. Failure could be, hey, I introduced some new update from my DevOps pipeline, some manual process. That's why we talk about, hey, different types of deployment strategy, maybe rings, blue, green, canary, whatever that is, to try and not have some self-induced problem hit inside the application. We want always that ability to roll back. Now, before we start talking about regions, when we think about architecting for resiliency, I drew this idea of, well, lots of data centers. And I talked about some of the things that could fail. Hey, the power from some substation, my networking, my cooling. And so what Microsoft actually do is when we think about within a region, most of them now expose this idea of availability zones. So that's an availability zone. Those data centers make up one availability zone. Those make up another. And these make up another one again. And the whole point of an availability zone is each of these sets of data centers, well, they have isolated power, i.e. use different substations, cooling, and networking. So if there was some problem of a substation, of some network, of some cooling, it would only take down and impact one of the availability zones in that region. And so when I think of architecting, I always want to think first and foremost, hey, make sure I'm using availability zones within that region. And there's different ways we can use those availability zones. Some services are what we would call zonal. And if something's zonal, what it basically means is when I create it, I pin it into a specific availability zone. i.e. I create a certain virtual machine and I put it in, for my subscription, AZ3. And so what that would mean is the emphasis would be on me as the customer to also make sure, hey, make sure you create an instance in another AZ and maybe another AZ as well. I want it in 3 AZ so I can do quorum. I have that resilience. So that's my emphasis to make sure I'm putting an instance in each of the available availability zones. The other option, this makes it easier for me, is if it is zone redundant. And that means it is taking care of maybe it's a standard load balancer and it has muxes and components that are in all of the availability zones. I don't have to worry about it. It's automatically distributing the components over the availability zones. Now, I still have to be cognizant of the fact that, hey, it needs to be able to create instances in multiple AZs. For example, things like virtual machine scale sets. An AKS node pool, which uses VMSS underneath. Maybe an app service plan. They have zone redundant options. You can think, hey, great, I'll create this VMSS, which is the same as an AKS node pool, service plan, and I'll create one instance in that. Is that zone redundant anymore? No, because it still has to go and create instances underneath. So even if I create zone redundant certain types of compute resource, make sure your minimum count is at least 2, ideally 3, so that it can go and then create for you instances across all of the availability zones. So if I say, hey, I want a zone redundant virtual machine scale set, and I set instance count to 1, it's not zone redundant anymore because it can only exist in one of the AZs. I would need at least 2, so it could at least be in 2 AZs, ideally 3. So don't ignore that fact that, hey, I still need to make sure my scaling is logical based on what I actually want it to do. And when I think about these, hey, multiple instances, they could be active-active. They could all be offering the particular service I want because they're very nicely tucked together. And so, hey, they can all be offering, they can have a load balancer distributing between them. I'm fantastic. But then we think about taking it up a level because we said, well, there could still be something that impacts the entire region. So if something impacts the entire region, well, what do we do there? Because as soon as I think about another region, okay, so that was one region, but now I'm going to think about, okay, I'm going to have another region. So if this was my region 1, well, now I'm doing region 2. And the problem becomes that light is really just not that fast. It's not fast enough for what we want. When I think about a single region, so my single region, one of the really important things is there's a latency envelope that really defines the region and all of the data centers and land parcels within it. So within my region, there is a 2 millisecond round trip latency envelope. And what that means is everything within that region, at most, is going to have 2 milliseconds of latency when it's trying to do anything. And that's actually pretty small. So what that means is, hey, if I've got a database, for example, well, I could have a database here, and I could have a copy of it. I could have another copy of it over here. And this could have synchronous replication. And the synchronous means, hey, if I get some operation to modify or create, it won't acknowledge that operation until it's persisted it here and it's persisted it there. So there's zero chance I could lose anything. Because at worst, I'm adding maybe a millisecond of latency to that operation request. I'm absolutely fine with that. And then I can think about, well, okay, then I could have my applications and they could all be active. So this could be my app and it's active, and this one is active. And even if they're in different availability zones, it's not a bigger deal. This can go and talk to this instance for read and write access. This one, hey, this can also go and talk to that instance for its read and write. Maybe this one over here is read only. Maybe I'll run some analytics against it or something. But if I'm a bit distributed within the region, it's no big deal. It's a super low latency. I can do synchronous replication. I can have active instances distributed around, still talking to a database in a particular AZ. I'm good. If I needed to guarantee really, really low latency, well, hey, there's things like proximity placement groups to try and get it into a specific part of a data center to get the lowest possible thing. But as soon as I change this conversation, as soon as I now think about a second region, well, let's think about it. Why did I want a second region? Well, the whole idea is if something nasty happened over here, that nasty thing would not also impact this one over there. So really what I want, therefore, is between these, I want a big distance. It's no good they're being 10 miles apart because then the horrible thing here could happen to that one as well. So for big distance, I want hundreds of miles between these. And as soon as I start thinking about hundreds of miles, well, that's now tens of milliseconds of latency. The bigger the distance, the higher the latency. And Microsoft actually has a little chart that we can look at, and it talks about, well, what are some of those round trip latency statistics between the regions? And now this is obviously pretty hard to see, but let's say you was going from West US 2, for example, this second to the end column right here. And maybe you wanted to see what it went to East US 2. I'm going to try and roughly trace the line. I may get it wrong, but it looks like it's roughly maybe 73 milliseconds. So 73 milliseconds of latency between if I was going East US 2 to West US 2. 73 milliseconds of latency is very different than 1 or 2. If I was to now think about my application architecture, let's say for my app, I now also put an instance over here. So I have an instance of my app here. Well, if I'm now trying to access this database that's got 70 milliseconds of latency and I do a write operation, that is going to be slow. That's a sad day. So we have to shift how we think about doing things. Hey, I would have maybe a replica of the database here. But again, it's 70 milliseconds of latency. Am I going to synchronously replicate to that copy over there? Absolutely not. I'm not going to make an operation on this database and for every operation wait 70 milliseconds so it persists it over here. So this replica, this would be async. I'm going to acknowledge the operation as soon as I've persisted it here and there, and then lazily almost synchronize it over to that copy. Now there's things I can do in the architecture. My application, for example, maybe it's mostly read heavy. hey, I'll read from that local read, because this will be essentially read only. I'll read from that one. But if I have to do a write operation, hey, I have to write against the writable copy over here, the primary. But then what if I have to do a write and then read straight away? Well, that may have not replicated yet. Okay, so in certain scenarios, I now have to read from that. So it introduces complexity to my architecture if I was trying to do an active-active on those. So I have to do things a little bit differently. I have to really think about it. So it's actually less common to have this idea of active-active like this. It's actually a lot more common to actually make this passive. So instead of this being active, this is now passive. So it's ready to take over in the event of a disaster, but it's not actually running and accepting requests all of the time. It makes it easier for me because now, hey, I'm just replicating the state asynchronously, but I don't have to worry about all the app architecture to handle, hey, how does that perform? What do I actually need to do? And there's different types of passive. So one type is hot. So if it's hot, this compute is basically running. So it's going to be a faster failover, but it's going to be increased cost because those compute resources are running all of the time. Or it can be cold. So if it's cold, what I actually do is I allocate the resources, start them, or create them. They're not even existing. I'll create it in the event of a failover. So then I'm not paying the compute costs unless there's an actual disaster event. So it's going to be a lot more cost effective, but it will take longer to fail over because I have to wait for that allocation, that creation to actually occur. So there's a certain amount of increased time with that. So it depends on what my recovery time objective is, which of those I might take. But this is far easier to handle than trying to do active-active. Now, this obviously doesn't help with if I have users distributed and I'm trying to give them a better all-up experience because there's still only one set of compute resources accepting connections, and it's only in a disaster I then fell over to the other region. But again, this is far more common, especially for relational databases, because handling this state is very, very difficult. I've got other videos on that, and I'm going to talk a bit more about that later on. But this is really a key point when I think about starting to introduce the idea of additional regions. But it is critical because no matter what this resilience I build within a region, availability zone is fantastic. It makes it far less likely there's going to be something that impacts the entire region. It could still happen. So if I really want to talk true resilience, I have to at minimum have the ability to recover to another region. And there's many different ways I could do that. It could be as low level as, hey, the backup gets replicated over there and I restore a backup. It's going to take me a lot longer, but I could do that. Or I replicate the state. Or I have entire compute instances running and ready to go. So I know then, okay, I want to use multiple regions. Which other regions should I use? We know we want a big distance because if I'm really thinking second region, I'm thinking second region because something could happen to this region. So I know I want a big distance. And Microsoft actually has some suggestions for us. If we go and look, they have natural pairings for most regions. So I can go and look at a region and there's a pair. So for every region, there is a pairing. So for example, I talked about East US 2 and West US 2, but actually that's not right. The natural pairing would be East US 2 and Central US. North Central US and South Central US. West US 2 and West Central US. So there are these natural pairings that Microsoft actually suggests. And we might say, well, why? Why do Microsoft have these pairings and what do they give me beyond me just picking my own? So let's look at that. So if we looked at my picture here, and let's say, for example, we had this idea of, if we take their scenario. So So in these regions, let's say region 1 was actually East US 2. And my region 2, their pairing was Central US. So they are regional pairs. I'm following the Microsoft recommendation of those. Okay, so great. Why? What does this actually give me to use those regional pairs? So there's a number of things. So the first one is, in nearly all cases, it is the same geopolitical boundary. If you think about, I have resources, maybe my data, maybe I'm not allowed to replicate it outside of my country or outside of the European Union or whatever that might be. So when you look at those pairings, the regional pairs are in the same geopolitical boundary. I'm not replicating data outside of my boundary. There is an exception. South Central US actually receives from Brazil South, because at the time Brazil South was introduced, there was not a second region in Brazil. So it replicates the South Central US. But for all of the other pairings, they're within the same geopolitical boundary. Now, there are regions coming along now, Central Qatar, that actually don't have a paired region at all. And we'll talk about that. Okay, so they're in the same geopolitical boundary. The pairings are ideally 300 plus miles apart. So they're not picking two regions next to each other because, hey, I want resilience for that. So it's helping me minimize the chance of a regional problem impacts the paired region as well. Sequential fabric updates. What does that mean? Azure makes changes to its fabric. It rolls out enhancements to resource providers, to Azure Resource Manager. There's all of these things it has to change, and very frequently. Well, there's a chance, and we talked about the things that can introduce failure, one of those introduces a problem. And what would be horrible is, hey, I have two regions for resiliency, my primary and maybe my DR, or I'm active, and that change that breaks something breaks both regions at the same time. And so with the regional pairings, Microsoft don't roll out the changes to the fabric at the same time. It's sequential. It would roll it out to the first region in the pair, wait, and then maybe a day later, roll it out to the second region in the pair. So if there was a problem, I know I could fail over to the other region, and that would not have got that update yet. So that's kind of an important part of what the regional pairs give me. It means if there's a problem, something breaks, I should be able to fail over and it would not have impacted that one. Now, depending on if I'm the only customer it impacts, if through bad luck, I'm actually running active on what is the second one to update, that doesn't apply. So it'll be very more useful if I'm active, or I've got some testing going on there. But generally, if there's something that breaks at a fabric level, many customers would get impacted. So, hey, hopefully, even if I'm not active on that other region yet, someone else was, and it stops, and I've got protection from that. So it gives me protection from fabric level things, hopefully breaking both my active and my passive region. So that's a pretty big one. If there was some global level outage, some huge problem, one in every pair is recovered first. I.e., Microsoft have a finite amount of resources, and hey, we want to bring up all of the regions as quick as possible, but they'll prioritize one out of every pair as part of their all-up first effort. So that again, hopefully, one of the two I can use is brought up first. So it gives me that capability as well. And then there is native replication for what is really a few services at this point. This is not as huge a deal as you might think. It's shrinking that really cares about those regional pairs. But there are some key services, think storage and key vault and recovery services vaults, that do replicate to those pairings. So that's definitely something I'm going to consider as part of that. But I don't have to use these pairings. They may not fit. Maybe there's not a paired region. Again, that central Qatar does not have a paired region at all. Maybe the paired region doesn't meet my requirements. Different regions offer different services, maybe even different capabilities. Take South Central. So South Central, for example, has availability zones. North Central does not. So its paired region doesn't have availability zones yet. And maybe availability zones are key to my resilient story. I don't want to fail over to somewhere without availability zones. I can't meet my SLAs, in which case the paired regions do not meet my requirements. Or maybe the paired region doesn't meet where I have data centers or client traffic or many, many other regions, but I just don't want to use them. It doesn't meet my requirement. So essentially what we're talking about here is then, so Central US was, for example, the paired region. I want to use a different region. So there's another region here. Maybe we'll say this is West US 2. And this is just my choice. I want to use a region other than the paired one. So I want to use these two. Totally can. I can use any region I want. I just have to think about a few key factors of what does it mean in terms of what am I expecting from those regional pairs. And again, there's a massive number of regions. If we go and look at the map, for example, okay, it's taking forever. I don't know what's wrong with this. Is always slow. I don't know what they're doing. Let's jump to a different URL. But the whole point here is we don't want to explore the globe. If I just looked at United States, for example, there are a lot of regions. Central US, East US, East US 2, East US 3, and I can scroll along. There's just a huge number of regions available to me. So I have lots of choice in what region I actually want to use. So great. I'll pick a different region that better aligns with my goals, maybe better aligns with the features I need. But remember, there were reasons that Microsoft paired the regions. So what happens if I pick my own one? Well, some of them are actually pretty easy. So this idea of same geopolitical boundary, 300 miles apart. Well, I can absolutely look at where the regions are. I can see what geography they're in, and I can pick. So I can still make sure they're a good distance apart. I can still make sure they're in the same, whatever that boundary of my geopolitical boundary of, maybe I don't care about data residency, it's not a problem. Maybe I do, well then I have to look at what regions would meet those requirements. But that's on me, so I absolutely can handle that. So for these, it's my choice. I need to look, I need to make sure it meets my requirements. No big deal. So that's easy. Sequential fabric updates. Now that's a bigger deal. That idea that as Microsoft are rolling out changes, they won't hit both of the regions. Maybe I'm using active-active or active-passive at the same time. And that one is very difficult. There's really not a good answer to that. However, the reality is when I think about this sequential fabric updates, what Microsoft actually do is they have this idea of safe deployment practices, this SDP. You might also hear the term availability first updates. And this is really all about the idea that as changes happen, which they will, it's not just big bang. It's done incrementally in rings so that if there's a problem, it's caught before reaching some majority population. Now, different customers have different configurations, different combinations, so you may be more unique than others. The more unique you are, the greater the chance potentially you're the first one this problem would hit. However, there's this whole set of rings. There's this idea that, well, there's internal Microsoft dev test stuff that goes on. Then they have their own staging, where again, these various test things are going on. Then there are these things called canary regions. So canary regions are, I mean, they're of a finite capacity. They have certain services, but if you're a Microsoft customer and you're big enough, you can request access to these canary regions and you can go and spin up resources in them. Now, you wouldn't run production in there, but I could run a particular set of resources and combinations of architectures I use very commonly, run it there, maybe synthetic workloads, and this will get the changes very, very early on that are coming down the fabric path. So I would get an early opportunity to see what's coming, to see, hey, does it have some negative impact on me? Then it goes to this kind of first real region. Then it goes out to some medium load region. Then it goes out to a heavy load region. And then it thinks about going out to that, okay, first region in a pair. Then the second in pair. And then there are just non-paired. So if you have a region that doesn't have a pair, they're last. They're non-paired region. And then you have the sovereign regions. So there's this whole set of paths, essentially, that go through to have changes. And between each of these, generally, you have 24 hours. They wait 24 hours, and they want a high percentage complete. It won't move on until that change has had a high percentage rolled out and is successful. So it's really gates. It's gates to make sure this change is good before it carries on down the path. And then even within a region, well, what it actually does, if you think about it, it's called multiple AZs, they're gates as well. So it goes to AZ, say AZ1, again, they're logical in a subscription, but there's a certain set of data centers. Then it goes to AZ2, then it goes to AZ3, and again, there's gates between all of those. So even if I'm not using the paired regions, there is still the idea of changes don't just big bang hit all of Azure. There are these gates. Some services even expose how they roll out updates. But I guess one of the key things to take away from this is availability zones. Really focus on the use of availability zones within the region, because that's going to give you a really good set of protections from many types of problems. Failures, hardware failures, data center failures, and those fabric rollouts, they are done that AZ by AZ. So that also would give you a very nice resilience from those types of changes. But AKS, for example, if I went and look at AKS actually exposes their release order. So when I talked about region 1, well, West Central US is typically that region for everyone. So West Central US gets updates very early for most services. But for AKS, then it's UK South, then East US, then Australia. You can see the order they roll out their updated images, which have the latest AKS updates and OS updates and those patches. But it gives you an idea of also what they do for the all-up, how they think about staggering AKS. And different services do different things. But hey, I can get some visibility into this. But again, what I would really take away is if you're a big organization, maybe you really want to start thinking about getting in these canary regions. Now, it is paid, it's resources. I'm not running production on them, but I would try and set up some basic set of architectures that reflect the majority of what I have out there in production, so I could get that early access as changes come. But definitely really, again, focus on those availability zones as part of that protection. So, hey, when I think about this sequential fabric updates, I can't guarantee that my regions don't get Fabric updates at the same time, but there are certain things I can do. Definitely AZs are going to help. Maybe to give me the most, I can look at the canary regions. But hey, that's a pretty nice thing the pairings do give you. So there's some limit to how I can do that. 1 in every region pair is recovered first. Honestly, there's really not a lot I can do about that one. Now, I think in reality, I've not seen this to really be a huge thing, but I guess if I'm completely honest, there's not much I can do. I don't know if that looks like that. This is what it is. Again, from the time we have seen big challenges, I've not seen this big staggering really of regions like that. So I think this is a very, very uncommon thing. But the reality is, okay, you are giving that up. There's not something I can guarantee that would have the same effect. Native replication. Now, it's important to understand that little bit that in the beginning, there was no concept of availability zones in Azure. And so the only way I could get resilience, even from a cluster problem, was I would have to replicate to another region. There was nothing else I could do within the region. Now we have availability zones, and again, because they do have these independent power cooling networking, it's far, far more common that I'm going to see an AZ issue than I'm going to see a regional issue. So I know I keep saying it, but using availability zones and having either multiple different zonal deployments or using zone redundant, that's really probably going to address 99% of the time you're going to have a challenge. But it's not the end answer. The reality is I still want protection if there was some regional level problem. And so there are these native replications that happen between the paired regions. So what do I do with that? Well, let's look at what those are. So the first one is Azure Key Vault. If I think of Azure Key Vault, I create an Azure Key Vault in a particular region. And then inside that Key Vault, well, I can have secrets, some string like a password that I can write and read. I can have certificates, so it handles the life cycle of those. Again, I can put those in, I can take those out. It does lifecycle management for me. And then I have keys. And keys are very different. So secrets and certs, they're easily writable, readable. I can get them in and out anytime I want. Keys, I either generate them inside or import them in, but I can't just then read them out again. I have to perform the cryptographic operations within the key vault. I can't just grab that key and put it wherever I want. So the idea here is with Key Vault, so there's the region I create the Key Vault in, and then we have the Azure paired region. And to that Azure paired region, yes, it's replicating. So the secrets, the certs, the keys, they replicate to that paired region. And in the event of a problem with this region, this paired region copy is read-only, but I can still go and get to those keys. I can still use the certs, the secrets. I still have access to that. So in the event of a disaster, hey, I can still go and use this. When this comes back, then it becomes read-writable again. So what if I want to use my other region? Well, remember, my other region could still go to the paired region for most services, and I have access. So I could still go and read the certificate. I could read the secret. I could maybe use the key. Now, depending on the service, sometimes the key vault has to be in the same region as the service. But as we're going to see, it's actually pretty rare that many services where it's like bring your own key, where that key lives in a key vault, is used as part of a different region's replica. They typically do not work that way because that would really limit what we can do. But if it's some application I'm writing and I'm using the key, I can still access it. It's just going across the region. But typically that's going to be okay. If it doesn't have a pair, remember, like Central Qatar, it uses availability zones to give me that resilience for those keys. If I'm using private link, that private link can maybe take 20 minutes to fail over. So there might, again, could be some gap in my connectivity to it. But what if I don't like this? I want to have a key vault over here with my content in it. Well, remember, secrets and certs, I can read and write those at any time. So there's really nothing to stop me. In this case, okay, I'll just write something that reads them and then writes them. That's easy. I can't do that with keys. It doesn't let me do that. But what I can do with keys is I can back up and restore. Now, when I talk about backup and restore, there is a boundary on this. So the region that I'm backing up from and restoring to has to be the same security world. And security worlds basically align with the Azure geographies. And we actually just saw that. So when I looked at a picture over here, when we said choose the right region, notice we have geographies, and I selected United States. Well, the geographies align with the security boundaries. So what that means is, hey, I could back up my keys anywhere in the United States and restore them to a key vault anywhere in the United States. I would not be able to back them up from a region in the United States and restore them to a region in Europe. That's a different security world. It will not let me do that. So that's just kind of a key point to understand. And again, let's turn off show nearby. So that's my geography, United States. If I was in Germany, well, there's only one in there. Australia, there's a few, so I could back up from Australia East and restore to Southeast or Central. So I can back up and restore those keys. So even though I can't just read them and write them within the same security world, hey, that's actually not too bad. I could go and back up and do that restore if I needed them specifically in a key vault in the same region. So I have a solution to that. But again, for most things, if I have some bring your own key solution, it's not going to use a key from a different region anyway. And we'll see exactly that. But maybe my app does, so I want it. So there's a solution to that. Azure Key Vault, we can do that. Okay, the next one is Azure Storage has GRS. I think it's globally redundant storage. And the idea here is you have 3 copies in your local region, and then it asynchronously copies to the paired region another 3. So this is the paired region. And also there's the option to make this read access for certain types of workloads. Okay, so that's to the paired region. What if, I need to get my colors right here. So this. What if I'm again in my other region, not paired region? So maybe there's some stateful entity in the storage account. Maybe there's certain log files or images written that I need available. And a little bit comes down to what is my recovery time objective? How long do I have to get up and running? Because technically, depending on the volume of data and the event of a disaster, well, could I copy? Do I have enough time to take it from the paired region and copy it across to my region? That may be a solution that may be good enough for what I actually need it to do. Okay, what else can I do? Well, obviously Azure Storage has many types of objects it supports. And for one of them, we have blob, block blob specifically. So for block blob, we now have object level replication. And what this lets me do is at a container level, so I have different containers in a storage account, well, I can say, hey, in this container 1, I want you to replicate to container 2 in this other region. And it will do the replication. Now, the thing it doesn't work with today. I don't think it works with Data Lake. So if I turn on the hierarchical namespace, it's not going to work. I can't use it today. I think that will change in the future, but I couldn't use it today. I could use things like AZ copy. So AZ copy has some really nice sync capabilities. So it will delta. It will look at what's changed from my source to my target. I think it works on blob, it works on files. So maybe, hey, I use AZ copy to copy from my source to my destination. And I could use that via something like an Azure function or a logic app. So it's serverless. It just runs on a certain interval. It'd be super easy to do. And I'll be off and running. So there's different ways I could solve that problem. But yes, I mean, the GRS is a nice option, but there might be things I could do. Depending on how long I have in the event of a disaster, maybe I could copy it. Maybe if it's blob, I could use the object level replication. Maybe I could spin up my own process every 5 or 10 minutes, which would then depend on my recovery point objective. Recovery time objective is how long do I have to be up and running. Recovery point objective is how much data could I lose in an unplanned failover. Now, this is async anyway. There's no guarantee of how up to date this is. You can go and look at the replication and see the last sync time, but it doesn't guarantee any particular time. If I wrote my own, hey, I could maybe run every 5 minutes or 10 minutes. Now, depending on the amount of data, there's a finite time it's going to take to copy it, but I could adjust how often that runs. And then we have things like the recovery services vault. So recovery services vault, some workloads, well, they back up into the vault. Now, many today don't. They might use native, maybe snapshot capabilities, and it's more of an orchestrator to tell it to go and create the local backup. But some of the things do still copy to the vault. And the vault, well, it can replicate, if I turn on the geo replication, to the paired region. But again, what if I have my other region? I don't want to use the pair. So many of the workloads, one option I could do is in the paired region, or anywhere, maybe the primary as well, I could actually do a recovery operation, but I can do a recovery to file. Like this works with, for example, many of the database, if it was stored within there. It restores into a file, and then the file, I could restore wherever I want. Now, again, it has to now copy that file across the regions, but that again, how long do I have? Maybe that's an option. Maybe I just write my own backup straight to file, and it stores the file in the other region, so it's locally available to be used there. So there are different options potentially available to solve the recovery services vault. Now, one thing we'll stress is we're going to talk about replication. Replication is not a replacement for backup. Sometimes those lines blur a little bit. Sometimes we might use backups for failover purposes. If our recovery time objective is long enough and our recovery point objective is flexible enough, I'm not going to bother replicating. I'll just restore the last backup. That's great. You're using the backup in place of replication. Replication can't be used as a replacement for backup. Replication is, hey, I'm copying data really as quick as I can, typically, to another location. So in the event of a problem, I've got as much up-to-date data as I possibly have. Backups are there to maintain a previous point in time. If there was some logical corruption, some logical deletion, I've maybe accidental, maybe malicious, maybe some bug, I can roll back to a previous point in time to undo that logical corruption. Logical corruption means something happened to the data. It's not a physical problem. The data got fields deleted or fields scrambled or fields encrypted by the bad actor. Backups let me roll back in time and undo that. So the key point about, I guess, all of this is I have options that I I can work around most of those things. So that's those native services. Okay. Let's think about the majority though. So that was Key Vault, okay, and a storage account and a recovery services vault. What about just my overall, my application? Well, if we think about most of our applications, so your application, your service actually probably is made up of n number of tiers. Most applications today are not some single VM. It's different parts do different overall components of the service. Well, typically they're housed and they're using different services. I might think about, well, okay, maybe, I'm just using an example, there's some web front end to receive and process requests, and likely in front of that there's some kind of load balancing solution. Maybe it's load balancer, maybe it's an app gateway, some regional instance of this thing. And then I've got some middle tier that's doing some business logic. And that's running on some services, and that probably, again, has some balancing to distribute between them that these go and talk to. And then there's probably a database. There's some back end that actually stores the stuff. And one of the things I have to think about when I start talking about multi-regions, especially, well, to be honest, active-active or active-passive, is, well, what are the requirements? What are the dependencies? What does it talk to? But where's the state? Because it's the state I care about. The state is where's the data that I need in the other region if I failed over, or I need to be able to talk to all the times if I was an active-active. And most commonly, if I was to look at like the web tier and the middle tier, there is no state that I really care about. The state is there in the database. So when I think about replication and making state available in another region, this is what I typically care about the most. And we already saw that idea of, okay, well, in architectures, maybe I have some async replica that I can read from, because this is the state. We didn't really talk about replicating a VM, or we didn't care. It's the state that was the important part that I need access to. So if I'm thinking multi-region, how do these things all come together? So these are really compute. These are primarily compute resources that we have for these tiers. So if I think about this, if I think compute resources, maybe there's an exception, but these are regional. I don't create a virtual machine scale set that scales regions. I don't create an AKS cluster that scales regions or an app service plan that scales regions. Compute resource is deployed into a region. And then the whole point of what I do is I would create instances of that compute service in multiple regions. I would create a VMSS in each region running its workload, zone redundant in each of them. I would create an app service plan in each region. And so for the most part, when I think about compute resources, they really don't care about regions, because they have no concept of being in multiple regions. It doesn't exist. They live within a certain region. And if I'm multi-region, I'm just creating instances in each of the regions, unbeknownst to an instance of that compute service in whichever region it happens to be deployed to. So if I think about that for a second, if I think, okay, I've got my region 1, and then any region, because it does not care at all about the idea of pairings, let's take a VM. Take the most basic thing I can think of, a virtual machine. There is no concept of multi-region virtual machine. It does not care at all. Now, one thing I will say, for a virtual machine, remember, fundamentally, where's the state? I have a managed disk. Now, a managed disk, I can use a disk encryption set and use my own key. That key has to be in a key vault in the same region. But if I replicate, it's not using the same disk encryption set. There'd be just a different one on the other side. So there's no concept of worrying about the key or the key vault. None of that would matter. What would matter if I used Azure Disk Encryption, because Azure Disk Encryption is using BitLocker inside the volume, or de-encrypt if it's Linux inside the volume, and it's getting the key from a key vault, and it has to be in the same region. Well, if I took the content of that disk and started it in another region, and I can't get the key vault, I can't open the disk. So a key point here would be just be careful of using Azure Disk Encryption if there's any concept of going to a different region. Honestly, the disk encryption sets and now the infrastructure level encryption is a better solution anyway. So I would steer clear of the Azure Disk Encryption and just use, hey, disk encryption sets, use infrastructure encryption, which will encrypt temporary files, the cache files, all of that locally on the host anyway. And then I can do away and I don't worry about that. Managed disks have never had a GRS option anyway. I can't replicate a disk to another region. Doesn't make any sense. The challenge was, what if a VM has multiple disks? Well, GRS would kind of replicate them on its own schedule. So they might be 2 seconds behind, 8 seconds behind, 3 minutes behind. When you try to start that VM, it's completely inconsistent. There's no guarantee it would even work. So there's no consistency between multiple disks. And so managed disks don't have a GRS option anyway. They could do ZRS. If I want to replicate a VM, because there's something important about that configuration or there is some state, what is my solution? Azure Site Recovery. Azure Site Recovery lets me replicate to any region I want. It does not care. It doesn't use paired regions. And so then it's going to copy the contents of the disk, and then in the event of a failover, hey, it will actually go and spin up the VM and connect it to that copied disk. So I'm good. There's no problem with that. Great, region of my choice. And then all the other compute services are regional. If I'm a virtual machine scale set, if I'm an AKS, Azure Kubernetes Services node pool, which uses virtual machine scale sets, if I'm an app service plan, I'm creating all of these within the region anyway. And again, I would just create a different instance. Over here, I'd have VMSS 2. I'd have AKS 2. I'd have app service plan 2. They're not related. They're completely separate. Now, maybe they live inside a virtual network. Remember, a virtual network is bound to a specific region. So I'd have 2 virtual networks. And I would just use peering. I can peer them together so that maybe there's replication going to go on. Well, now they have an IP path between, if there was some like maybe a database running inside a VM or some service they need to talk, they can talk. I've connected those together. So I have that capability. Now, one thing I should stress, when we talk about these compute services, realize we talked about Azure Fabric, and the Azure Fabric has that safe deployment practice. It rolls out in those rings. I have control of that. But there are other things that happen. On a VM, for example, well, I don't know what color to use. We'll use this one. On a VM, with an OS inside that VM, there's patching. And that's nothing to do with Azure. Sometimes maybe it's auto-update inside the Windows OS or the Ubuntu. We saw that with AKS. It's just going out and saying, hey, are there any updates for me? Oh, well, I'll apply it. There's nothing Azure Fabric can do to control that for the most part. So I need to make sure I'm doing something to maybe stagger updates between regions or between, I want to see it in test dev first, make sure there's nothing that breaks my app, and then roll out patching of the OS to my production environment. So I have to think about that. I want to be able to stagger it. We're saying like AKS, well, there's Kubernetes. Kubernetes rolls out new versions. So again, there are ways to roll out the new version to AKS, but again, there's ways to automate that. Don't automate it to apply to your dev, test, and prod at the same time. There's stable, there's rapid, there's different options to auto-update. Maybe dev test gets it early, but are you stable in production? I always want to have the chance to make sure if there's any change introduced, I see it in my dev test before it could possibly impact my production environment. So make sure you think about these things as well. If I'm an app service plan, remember there's runtimes. Hey, a new version of .NET or Node, whatever that might be, if I turn on auto update of those, again, is it going to update my dev test and prod at the same time? Maybe it breaks something. That's a bad day. So always, always, always be careful. Anything that's automatic, careful of automatic. Do all the things we want in Azure Fabric, but if there's something else happening inside the actual resource, if Azure doesn't have control of that and is not doing that staging, I need to make sure I'm doing something. So I always want to think about, hey, apply something to test first and have a gate. I don't know how to draw a gate. That's a terrible gate. I'll draw the word gate. Have a gate and then roll out to prod. And ideally, maybe stagger if I've got active-active to different environments. Don't just let it automatically roll out throughout the whole world. Now, one interesting thing, when I start talking about multiple regions, I talk about the compute services in particular. If I'm active-passive, do I need these to exist? Well, it really comes down, remember, what is my recovery time objective? How long do I have? In the event of a disaster, how long do I have? Could I just create these at failover time? So they don't have to exist. I'm not paying for them. I don't want to pay for compute resources I don't need if they're not doing anything. I hope I never have a disaster. I hope I never fail over. Now, you should be failing over periodically to make sure your failover process works, to make sure I've not forgotten something, but I really hope it's not very often at all. So do I want these running 24/7 all year when maybe I only use it for 3 hours every 3 or 4 or 6 months? No. So depending on my recovery time objective, maybe I just create them at failover. Now, there are some things to think about. If there was a true regional disaster and every customer is failing over at the same time, there might be capacity constraints. So maybe there's some tier 1 critical services. Maybe I have a capacity reservation or I have some small elements so I could run some core services there to make sure it can be there straight away so I'm not maybe battling and have some challenges. Again, the more flexibility you have in which region, the greater the chance you're not going to see that problem anyway. Now, maybe the way you create things is you have pipelines. Now, if I think about something like a Git repo, most of the big repositories and the DevOps environments are actually just regionally distributed anyway. They're not in a region. They're just going to be available to you. So I should be able to have the infrastructure as code, whatever I need, to be able to go and create my environment. But if I'm using the shared image gallery, or what is now the Azure Compute Gallery, well, that is created in a particular region. Well, I can add replicas. So I would make sure I have a replica of my Azure Compute Gallery in the region that I want to fail over to. So I'd make sure I add that replica. It's going to cost me a little bit more money, but now all my artifacts are available locally in this region, so I can create them. Maybe it's an image, maybe it's some other artifact. Same as if I'm using containers. I have the Azure Container Registry. Once again, Azure Container Registry, if I had the premium SKU, well, I can add a replica of my Azure Container Registry as well. So my images are available here, so I can go and create my pods running on my Azure Kubernetes service environment in the event of a failover. I'm not struggling with this. So all of these are regional. There's not really a huge concept of the service of failing over. This would be me using it and starting this off and me doing something to actually move those services. And remember, even if these are using some kind of Azure Key Vault, they're only going to be using it locally. I would have a different Azure Key Vault on this side that these would use. Now, again, if there's some secret you need, and it's not the paired, remember, you can do those maybe function to copy the things. I could do that backup and restore on an interval. I can solve that if I do need it shared. But most of these concepts, if there is some maybe customer managed key for encryption, this is a different instance. It's not using the same key. It's completely separate. It would use its own local Azure Key Vault as part of that. So for log analytics, typically they'll be local, but if there is some global thing, hey, I could have that in another region available for me. One thing I would just stress when you think about resiliency, and this is really not specific to this, make sure you're using managed identities. Managed identities have very long-lived tokens. They pre-refresh them well in ahead of them expiring, and they have the ability to use regional authentication endpoints. So these regional authentication endpoints in the regions, the managed identity would just use. So if there was some Azure AD global issue, managed identities typically will just survive. It will not care. It will just carry on and you're good to go. So that's the compute. There's no state. I'm not replicating things. I don't care. But there was state. There was state over here. So how do I handle the state? And I really need to understand what is my recovery time objective and what is my recovery point objective. How long do I have to fail over and how much data can I afford to lose? The way most relational databases work, I have a primary writable copy of the database. So I can think about, hey, I have my database. This copy is the primary and it's read-writable. If it was encrypted with a customer managed key, yes, there's going to be a key stored in Azure Key Vault that's local to the region of the primary. And then my app, hey, it quite happily does read and writes when it's running. Okay. My other region over here, well, what do? We can asynchronously replicate. So this could be marked as read-only. And I might have multiple replicas in a certain region. They would use their own key vault. At a database level, I set customer managed key. And this is common across Postgres and SQL and MySQL. So these would have a completely different Azure Key Vault that this uses. And technically, if I had multiple replicas in the same region, sure, they could use the same key from the same key vault. If they were in the same, if these were both in region 2, they could absolutely do that. Maybe I'm running some analytics workload against a read copy. Doesn't need to write, it takes some burden off of the read-write copy. But I could also have a completely different set of regions. I could have multiple regions. I can have n number of replicas. It depends on the exact technology, but I can absolutely stand that up and have these. So that's a very common scenario to have. Now, if I have active-active, so this was active-passive. There's an app here, there's no app running on this replica. As soon as I introduce the concept of active-active, now there's an app over here. And as we drew in the other picture, it gets a lot more complicated. Sure, I can do my read request against its local read replica, but any write has to happen across. Now, most apps will be maybe 90% read, and there's a lot less write. So this may work. This additional latency when it rarely has to do a write may be fine. But realize, if I've just written something, maybe I expect to then see it when I do a read, when it's not replicated here. So I have to have logic to make sure I have certain consistency when I then go and do a read. So multi-region active-active can be complex, not really because of the application of compute. It's just how you're going to handle the state. What is the consistency the app needs to see to make sure I get that consistency? This is where things like Cosmos DB can really shine. And again, it does not care at all about the paired regions. For Cosmos DB, I can set the consistency. So is it eventually consistent? Is it consistent within a certain session? And is it strong consistency where only one of them is writable? So the whole point here is that I could have multiple replicas. So replica over here. I can have a replica over here. Imagine these are all separate regions. There's another replica over here. So I'm in 3 different regions. And I have an app instance, or multiple app instances in each region. And these read-write to their local replica. Depending, maybe this is a shopping cart. I don't have to all see the same thing. Because what I can do is I could say something like session. So with session, any app instances sharing the session would see the same content. They'd see the same order of read and writes. So maybe I have different sessions in each region that are then shared between them. And then what Cosmos DB would do is it would replicate as quick as it could. It will bring them into eventual consistency, but within the session, they would always see the same thing. So this is really useful if I want to do the active-active, and then I can have that local read-write. I don't really have to think about a whole set of work with that. It really comes down to the app. It comes down to what the app wants, what the app sees. And I guess finally, no matter what solution I do, I guess I'll draw it here just for the sake of it. If I have failover, active-passive, if I have active-active, well, whether I'm active-active, whether I'm active-passive, the end client can't have to know, hey, it's failed over, go and talk to a different endpoint. Or it's active-active, well, I should go to this one, someone else goes to a different one. So you always have to have this idea with multiple regions of some global load balancing. And there's different solutions for this. Now, all of these solutions would have things like a health probe to say, hey, which instance is up and running? Which ones should I direct them to? So they'd have a back-end set, possible targets, which are all of the possible. These would probably have a local, regional, maybe app gateway if it's layer 7, or a load balancer, something to distribute between the multiple instances that are spread over AZs within the region. Then I have some global load balancer to actually, hey, check they're healthy. And then how does it route? Is it active-passive? Is it performance-based? Hey, if I'm close to this one, send me to the one that's closest to me. And there are different solutions. So there's solutions with DNS, and that would be Traffic Manager. And again, I've got whole separate videos. I'm not going to go into the detail of this. If it was layer 7, like HTTP, well, then there's Azure Front Door. And with Azure Front Door, I could put Web Application Firewall to give it more security. Now, Azure Front Door does talk to Azure Key Vault, potentially, if I'm bringing my own certificates. So I'd want to think about, hey, that Azure Key Vault. If it's layer 4, well, there's now a global load balancer that can go and point to local load balancers. So, hey, if it's not layer 7, maybe I use the global load balancer. But there's all these different solutions to me, and we covered a huge number of things. But I guess my key point is typically you can use whatever region you want. Yes, there are benefits to the paired regions. The biggest one that I can't really replace is this sequential fabric update because, well, I can't control that. But again, if you look at the safe deployment practices, if I use AZs within the region, it's still giving me a pretty good set of protections from that. I can't replace the one in every pair is recovered first. Nothing I can do about that. Native replication, it really only applies to a few services. And most of the time, there's maybe other options. Or when I look at like stateful things that have custom managed key, when it has a replica of like a database to another region that I can pick, they don't care about the paired regions, it's using a local key vault. It doesn't share the key vault with the primary anyway. The encryption is at a database instance level. The replicas are their own database instances. It does not care. Computer services are nearly always regional. They don't care about another region. They have really no concept of it. It's something I'm doing separately. I create completely separate instances in the other regions. And then the point is I would balance between them. Where it really matters is the state. And if you look at really all of the database solutions, they don't care about the paired regions. they would let you async replicate to pretty much any region you want. Cosmos DB, I just check the boxes for what regions I want. It just doesn't matter. The key point is don't introduce single points of failure. Make sure you really understand your dependencies and make sure you test your process. Whatever regions you're going to use, as part of your change control, when you introduce some change to your architecture, make sure you're reviewing the change process, your DR process. Make sure you've not missed some new component. Test it periodically. Actually fail over and make sure it behaves. You don't want to work out something's broke during a disaster. That doubles a disaster. Azure Chaos Studio is a nice little tool to simulate certain types of failures. So maybe you could leverage that to test some of your processes out. But I hope this helped. I hope it helped kind of think about these things. Again, AZs, they're phenomenal. They're going to cover 99% of the challenges. But yes, I still want to have another region, be it active-active or active-passive. And hopefully this covered all the things you would think about. That's it. Until next video, take care.